Alright guys, a tangent we need to know. Remember, a tangent is a line that only touches a curve at one point. Basically, we need to recognize... Hey, that's rude. Sorry, I don't know what happened there. Okay, let's start again. Alright, a tangent is going to be a straight line. Okay, that's what I'm trying to say. Sorry, straight. Always. Alright, the tangent, whenever you see the word tangent used in any context, it's always a straight line. So in this section, we are going to be finding the equation of a tangent. Now we need to remember that a straight line always has this standard form. Y equals mx plus c. So our final answer to all these questions will have to be in the form y equals like 2x minus 1 or whatever. Alright? Or maybe just y equals x. Or, yeah, it's going to be in that form. You'll see when we do examples. So basically, we're going to have to calculate two things in these calculations. We're going to have to calculate the gradient of the line. And then we're going to have to sub in a point to find the c value. Right, so I'm going to add to that a little arrow going from c. We are always going to have to sub in a point on the tangent. Okay, remember from previous years, if you are finding an equation of a line and you're subbing in a point to get your c value, you have to sub in a point that actually lies on the line that you're finding, right? Sometimes you're finding a line here, you have a point down here, and then you just want to sub in any point that you can see. So you just sub in a point down here. All right, but it has to be a point that actually lies on the tangent, so on the line that we're trying to find. Now, guys, from our first calculus note, remember that page that I handed out to you guys that we made all sorts of notes on? I just want to point out something that we wrote down. Let me just go back quickly. I think it was over here. Right, this is the page that I'm talking about. Remember this one where we chose different points, getting closer and closer to a specific one. So guys, we wrote this down. This was the first thing that we wrote down. We said the gradient of a curve at a specific point is the gradient of the tangent to the curve at that point. Does that ring a bell? Right, and then what did we say? How do you find the gradient of a curve at a specific point? What did we end up saying on the next page? You remember here, I'm looking at the bottom here, we said that the gradient is equal to the derivative. Right, do you remember that? That was the whole point of this long, complicated story, right? So the gradient of a curve is the derivative. And then also the gradient of a curve is the gradient of a tangent, or of the tangent to the curve. So guys, what I'm trying to get to is that the derivative is going to give us the gradient of the tangent. Okay, we're going to write that down now. Let me just go back. Okay, so from our m, where we wrote m here, to get the gradient, we are always going to do the same thing, the gradient of the tangent. All right, always the same thing. So gradient of tangent is equal to derivative of curve at the point of contact. We'll talk about that some more just now. That's very important. So maybe highlight that sentence that we've written there. The gradient of the tangent is always, this is always going to be the case, guys, the derivative of the curve at the point of contact. We'll talk about that point of contact thing just now. But for now, we all know how to find the derivative of a function, right? If they give us the equation of a function, we can use the power rule to find the derivative. Okay, so that is always going to be our first step. Alright, so let's quickly go back to the first example here. They've asked us to find the equation of the tangent to this function. So guys, for the gradient, we're going to find the derivative of this function, right? F dash x. Okay, so what I would like you to do is just write y equals mx plus c. Or, I don't know, those of you that weren't in my class last year, you might not have used the second form of a straight line equation, but I think we did this when we did analytical geometry, right? Does the second formula look familiar? You can use either one of them. Okay, I'll show you how to use both, and then you can decide which one of these two formulas you want to use. You'll get the same answer in the end. Okay. For the gradient, regardless of whether you use this formula or this formula, we're going to do the same thing. The gradient is going to be f dash x at the point of contact. Now guys, what are they telling us here? They're saying find the equation of the tangent to the graph of this function at x equals 2. That is the x value of the point of contact, guys. Right, so that at x equals 2, that is the x value that we are actually going to have to use to get our gradient. I'll show you now how we're going to do that. Right, can we find the derivative of negative x cubed? Negative x squared, sorry. Negative x squared. Using the power rule, we're going to say negative 1 times 2 is what? Negative 2, and then x to the 1, or just x. So you multiply and then you minus 1 from the exponent. Next term we have plus 2x. What's the derivative of that? Plus 2. X to the 0, hey? Which we don't have to write. What's the derivative of 3? 0. So this is the whole derivative. But guys, as it stands, have we ever seen a gradient with an x in it? That's not normal, hey? So that is now where this x is going to have to be replaced with the x value of our point of contact. That is going to give us the actual gradient of this tangent. Alright, so now we're going to say negative 2 times 2. So I'm replacing that x with the 2, which they gave us in the question, plus 2. So there are lots of 2's now. Just make sure that you know where that second one is coming from. It's the point of contact that they told us about, right? I'll highlight it up there as well. So what is this now? This is negative 4 plus 2 is negative 2. So the gradient of our line of the tangent is negative 2. Now guys, I'll show you how you can work out what the full equation is using either one of these two formulas. So now we're going to say y is negative 2x plus c. That's the one formula if you want to use that. Or if you want to use the second formula, which I do prefer actually, it's y minus y1 is equal to m. Again, m is just the gradient. X minus x1. We need to sub in a point. Now guys, a point consists of an x value and a y value. The point that we have on the tangent, right? Can we just kind of visualize what this looks like? What kind of graph would this one be? If you had to draw this. This is a parabola. And is it an upwards facing parabola or downwards facing parabola? Down. Okay, good. Because our a value, the number in front of x squared, is negative. So it's going to look like this. Okay, and then somewhere on this line or on this curve, we have a point at x equals 2, and then the tangent is drawn there. Guys, the only point on the tangent, because remember, what did I write here? We need to sub in a point on the tangent. The only point on the tangent is actually that point of contact that they've given us. I can't just sub in any point that's on the parabola, right? That won't give me the equation of this line. I need to sub in a point that is on the tangent. So the only point that we can sub in is the point of contact. Okay, did they give us the full point of contact? Did they give us an x value and a y value? No, they just gave us an x value. Alright, now what must I do with that x value to find the y value of the point? Sub in to what? Remember, the point of contact is the point where the parabola touches the tangent. We have the gradient of the line, yes, but we don't have the c value. Guys, I'm going to say that again. The point of contact is basically the point of intersection of the parabola and the line. Do we agree that the point of contact is also a point on the parabola? Okay. Yes, so we're going to sub this into the parabola equation. Let's make a note, guys. Here, x equals 2. The point of contact is the point of intersection of the parabola and the tangent. Therefore, sub into parabola equation to get y value. No, for both of them. We need the point either way, yeah. Sometimes, guys, they're nice and they give you the full point of contact. All right? Sometimes they'll say at the point 2, 7, whatever it is. But often they just give you the x value of the point of contact. So then you need to sub that x value into the function. In this case, it's a parabola, but it can be any curve. Okay, it can be a cubic graph, whatever. You'll see later. You sub your x value of the point of contact into the original function equation to get that y value. Okay, so now, guys, you can decide where, obviously, maybe you are writing down both of these. It's up to you. For the point of contact, point of contact, remember it was x is equal to 2. That's what they gave us. And now to get the y value, we need to make x equal to 2 in our original function equation, which was up there, right? That parabola equation. So negative 2 squared plus 2 times 2 plus 3. Right? So wherever you have an x in that equation, you replace it with the x value of the point of contact. Okay, so this is, you can obviously use the calculator also to work that out. The first term is negative 4. And then you have plus 4, that's 0, right? And then plus 3. So the y value is just 3. Okay, so what is my point of contact? The point 2, 3. Okay, so now that is the point that I'm going to sub in, guys. So when you are subbing in a point, please, it's important that you actually write down the point that you are subbing in with a colon just after it, just so that the marker can kind of follow what you're doing. And I'm going to do now both methods so that you can see which one you would prefer. So if we're subbing in the point 2, 3 into this formula, right? 2 is x and 3 is y. Yes, does that make sense? Coordinate form is always x and then y. So guys, the y in this equation I'm going to replace with 3. And the x I'm going to replace with 2. Then the only variable that's going to be left is c. So I can then solve for c. Alright, so y is 3 equal to negative 2 times my x value of this point, which is 2, and then plus c. Now you can show as many or as few steps as you want here. You can decide. That is 3. This is negative 4 plus c. So to get c on its own, I need to move that negative 4 over, and it's going to become plus 4. Yeah, so we're going to have that c is equal to 7. Or 7 equals c if you want to, that's fine. Therefore, the tangent is y equals negative 2x plus 7. Final answer. Okay, that is if you use the first formula, this one here. Or I'm just going to show you how the other one works. Again, we are subbing in the point of contact. Now, for this formula, notice that we have a y minus y1 and an x minus x1. So when we're using this formula, our x value is x1. And our y value of the point is y1. Okay, that's how the second formula works. So we're going to say y minus 3. Y minus the y value of the point is equal to negative 2 bracket x minus 2. X minus the x value of the point. I'm going to multiply the negative 2 into the bracket. I'm going to get negative 2x plus 4. You can rewrite y minus 3 if you want to. And now what must I do to get rid of this minus 3? I just need to add 3 to the other side. So you're going to be left with just a y on that side and negative 2x plus 7. So using the second formula, you're not actually going to get a c equals something. Alright, you just put your x value and your y value in, you multiply your bracket out, you move that number over, and then that is the equation. Yes?
Second formula,
Mm-hmm.
so are you always having an x and a y? Like,
Are you always leaving an x and a y?
like, are you always
Yes.
just
Yeah, so you're going to have your y and your x. So the first y in the formula and the first x in the formula you leave, and then you put the y value of the point, x value of the point. Okay.
and then for the tangent of y equals negative 2x plus 7,
Mm-hmm.
where did we get this formula that was given?
It's from this.
Okay.
So it's from using your y equals mx plus c from grade 9.
Okay, and the final equation of the change to the graph of the function, is that us just working out the point of contact?
So the point of contact was 2, 3, which we used there, but the final answer of the question is the equation of the line, the tangent. So this is always going to be your final answer.
So what is the negative x squared plus 2x plus 3?
That's the parabola. So they've asked you, they've given you the equation of the parabola, they've asked you to find the equation of this line. Okay, which is that?
Oh, because they both allow, they both share.
Yes, they share the one point, which is the point of contact.
Okay.
Right, any other questions on this one? We're going to do another one quickly, which is similar, just so that we can get the method down. And guys, for these questions, you are always going to apply the same method. Alright, the only thing that might be different is that sometimes they might give you the full point of contact, in which case you don't have to calculate it. Right. Yeah. I'll have to check an actual final paper to see how many marks they give. I would say 4 or 5, but it's probably 4. I'm going to do it with you, yeah. Alright, so again, same question. Find the equation of the tangent to the graph of f. They've given us the equation at x equals negative 1. So this is the x value of the point of contact. Alright, have they given us the y value of the point of contact? No. So we're going to have to figure it out, calculate it, by subbing that x value into the original equation that they gave us. Alright, so we need to remember that our gradient is always the derivative of the function at the x value of the point of contact. It's fine if you just write f dash x, but you do have to remember to sub in negative 1. Okay, because your derivative is always going to have an x in it, your gradient. And a gradient has to be a number. Okay, so let's use the power rule to get the derivative of this. If we have negative 2x cubed, we're going to say negative 2 times 3 is negative 6x squared. We minus 1 from that exponent. Plus 6 times 2 is 12. And then x. Because it was x squared, we minus 1 from the exponent. What's the derivative of 4? 0. Okay, so this is the derivative in terms of x, meaning that there are still x's in there. But now we need to put x equals negative 1 in the place of those x's. So now we're going to say negative 6 times negative 1 squared plus 12 times negative 1. Alright, so negative 6 times negative 1 squared, guys, this is actually just going to give us 1. Right, so this is negative 6, and then this is minus 12. So the gradient here is going to be negative 18. Okay, so that is our m value. Next up, we need to find our point of contact, because that is what we're going to sub in. Alright, so I'm just going to write again, point of contact. The x value that they gave us was negative 1. And to get the y value, we're going to sub negative 1 into the original equation. So we're going to say y is equal to negative 2 times negative 1 cubed plus 6 times negative 1 squared plus 4. I think, is it 8? Or is it 12? Here we go. So negative, so that's 2 plus 6 plus 4. Okay, yes. 8 plus 4 is 12. Yes, thank you. Okay, so we're getting 12. So the point of contact is negative 1, 12. So that's what we're now going to sub in. Again, I'll show you both methods, and you don't have to write down both. If you've now decided you want to use the first one or the second one, you can just write down that one. Alright, so we have in the first method, it will be y equals mx plus c. But what was our m? What was our gradient? Negative 18. So negative 18x plus c. And then you would sub in your point of contact, which was negative 1, 12. So the y value is the y value of the point, which is 12. That's equal to negative 18 times x, which is negative 1, plus c. Again, you don't have to write the next step if you feel like you don't need to. But that is going to give you 18 plus c, right? Because negative 18 times negative 1 is just 18. So c is going to be 12 minus 18, which is negative 6. So then from there you can get that your equation is y equals negative 18x minus 6. Okay, that's using the first method. If you want to use the second one, I'm just going to write it on the side here. It's y minus y1 equals negative 18. So m times x minus x1. That's how the second formula works. We are still going to sub in the exact same point, the point of contact. It's the only point we can sub in. Now we're going to say y minus the y value of the point, so y minus 12, is equal to the gradient, negative 18, times x minus the x value of the point. Now guys, what is minus 1? Plus 1, hey? So here we're going to have to put in x plus 1. You're always subtracting the value of the original point. Just quickly going to multiply that in. So we get negative 18x minus 18 And now I must just add 12 to that side. So I'm going to say y is equal to negative 18x, and then negative 18 plus 12 is also going to give us negative 6.